Alright, welcome back. This is Chapter 7, Section 5, entitled Apply Properties of Logarithms. You should already have a copy of the note-taking guides, and we're going to go ahead and just get right started. There are no vocabulary words to go over, but right away you'll see that there are some properties of logarithms. These properties, you can see there's no numbers here, but they could be numbers, they could be variables. You just have to know that right here, this is multiplication going on between here and here. That means when you are multiplying two numbers, like taking the log of the product of two numbers, it's actually, you can break that up and make it the addition of both of two logarithms. This is called expanding. This is called expanding logs. And hopefully it should kind of make sense, because do you remember here when you were the square root of AB? This can be rewritten as the square root of A times the square root of B. You can break multiplication up. It's somewhat similar to that, but instead of multiplying, you actually are adding. So think about the property that says if you have x to the a times x to the b, what did we do to the exponents? What did we do to them? Same base, so you rewrote it as x a plus b. Right? So it's just properties like that. You just have to recognize multiplication, and so then you break up the logarithms into two parts. The quotient property. Now, if you added the two logarithms when multiplying, if you're dividing, you simply subtract the two logarithms. That's how that's set up. And then the power property says if you have a log base b of m to a certain power, you can rewrite that to n, put n in front of the log. So it should be written like that. And we're going to do some examples here in a second. But basically, again, this is multiplication, so you add two logs. Division, subtract two logs. And power, you put the power in front of the logarithm. So let's check out these examples. Log base 5. Log base 5 here, 4 over 9. Now I know that we've talked about this change of base already. And I know I've said that you can rewrite things. So you could rewrite log base 5 of 4. You could rewrite this as log of 4 over log of 5. And so you could use the change of base formula here. But since they want us to practice the properties, let's actually practice it. Division. That's the quotient property. So when you're dividing, you have to take m, log of m, and then subtract log of b. So it should look like that. Log base 5 of 4 minus log base 5 of 9. Now the reason this information is given to you is that now you know what log base 5 of 4 is. This part right here is 0.861. You're going to subtract log base 5 of 9, which is 1.365. And when you type that into your calculator, or if you just simply subtract, you end up with an answer of negative 0.504. The quotient property is what you really need to be practicing right now, though. Here, log base 5 of 36. Well, 36 can be rewritten as log base 5 of 4 times 9. Now, of course, you could use the change of base formula. You could use the change of base formula and say that this is just log 36 over log 5. And hopefully, well, and it should give you the exact same answer. But to fill this out, write 36 as 4 times 9. Use the product property. Product property says to add. And now you're simply taking 0.861, adding it to 1.365, and getting 2.226. Now you should be able to use a change of base formula to check that if you want. Remember, you type log, you put the first logarithms in parentheses, so log base 36 divided by log, oh not base 36, but log 5, and you get 2.226. So using your change of base formula here should work, or doing it this long way as well. All right, log base 5 of 81 is equal to, all right, it's telling you that we need to rewrite 81, and you're going to rewrite it as 9 squared. And hopefully you see that this is power property. So the power property says to put the exponent in front of the logarithm. So really, using the given values, you're doing 2 times 1.365. If you wanted to use the change of base formula, you could rewrite it as log 81 divided by log 5, and it should give you the same answer as we get right here. All right. So we're going to try to use this, do this the same, do both ways here, change the base formula and using the properties. Using the property here, 4. Well, we have a 2 and an 8. None of that, the best way to set this up is to look at 4. Log base 3 of 4 is actually log base 3 of, you can actually do this 2 ways. Let's do this, let's do the power property. Let's say that 4 is 2 squared. Right? 2 times 2 is 4. So now, power property says to put the exponent in front of the log. We know that log base 3 of 2 is 0.6309, because it tells us up here. And when you multiply those together, you should get then 2 times that number, gives you 1.2619. The change of base formula, you would simply type log of 4 divided by log of 3, which also will give you 1.2619. All right, over here, this checkpoint example, log base 3 of 16. Well, 16, you could rewrite a number of ways. I am going to say that it's 2 times 8. So now you should see that there is multiplication, and all you're doing is log base 3 of 2 and adding it to log base 3 of 8. Now the reason I chose 2 and 8 and not 4 by 4 is because here's a 2 and here's an 8. And now it's a matter of doing 0.6309 plus 1.8928. And when you add them together, it's 2.5237. And of course, the change of base formula, all you'd have to do is log 16 over log 3. And you should still get 2.5237. All right, guided practice 1 to 4. We're not going to do all of them. For time's sake, I don't want this video to take too long. Let's take a look at number 1. Now you should be following in your book as well, so I don't have to write everything down. Number 1 says to do the log base 6 of 5/8. And in the directions, it tells you what some of these logarithms are. So, division, the quotient property. You're supposed to subtract the two logarithms. This is expanding the logs. And in the directions, it says that log base 6 of 5 is 0.898, and you're subtracting 1.161. And when you subtract that all out, it becomes negative 0.263. Number 4, log base 6 of 125. All right, well, the property way, using properties and expanding this, you would say that 125 is 5 cubed. And using the power property, just like the example over here in number 1, you take the power and you put it in front of the log, and it becomes 3 times 0.898, and you get 2.694. Change of base formula, all you'd have to set up is log 5/8 divided by log 6, and you'd still get 0.263. Over here, it'd be log 125 divided by, it's a 5, divided by log 6, and you'd end up with the same answer of 2.694. All right, that should help you with this next part of expanding logarithms. Now, agree with you, this looks a lot more difficult than what we just got done doing. But it's just asking you to expand the logarithm. So look at the numerator. What operations are going on here? I see some multiplication, I see an exponent, I see some division. Now, it tells us to use the quotient property first. So, quotient property says log base 3 of the numerator minus log base 3 of the denominator. It's this one right here. Right? That's why this is an important way for a thing for us to know how to do. Yes, change of base formula would work very quickly each time, but we need to know that when there is a quotient or a fraction, it's log of the top minus log of the bottom. So that's what we did. We used the quotient property. Now it says to use the product property. Well, 7 times x squared, that is a product. So when you are multiplying, you just break up the multiplication and add. So log base 3 of 7 plus log base 3 of x squared minus log base 3 of y. The last one you should see is there is a power left over. The power property for logarithms says to put the exponent in front of the log. And that has now been expanded. We're going to do a couple examples and some checkpoints, and then the guided practice for this. So let's take a look. Now we did some expanding. Let's do a condensing. Condensing every time. The key here for condensing is start with the exponent. Actually, let me rephrase this. Let me rewrite this. For this one right here, for expanding, you need to use the quotient property first, then the product property, then the power property. So basically, step 1, look for fractions. Step 2, this is for expanding, everyone. Can I write sideways? For expanding, you look for fractions, and then use the quotient property. Look for products, and use the product property. And then the last thing you should do at the end is look for exponents. Over here, the first thing you should do is the reverse of this. First, look for coefficients. Right? This is a coefficient. Coefficients turn into exponents. Then look for subtraction. Because subtraction turns into, oh, I'm sorry, we're working the other way. So don't look for subtraction, look for addition. Which turns into products. And then thirdly, we look for subtraction, which turns into division. Right? Basically, subtraction goes in the denominator. Addition goes in the numerator. So, that being said, here is a coefficient. So that coefficient becomes an exponent. Now the space that's here most likely means that this right log base 3 to the third power actually is log 27. All right? And so now what we're doing is taking log 2 plus log 27. In the product property, if there's addition, it means product. So 2 times 27 should be 54. So this now becomes log base 54. So we've looked at the coefficients, we put together with addition. Now the subtraction becomes a fraction or division. The 54, things that are positive, go in the numerator. Things that are being subtracted go in the denominator. So when you simplify this, it becomes log of 6. And you could evaluate this if you wanted to. Log 6 is 0.778. All right, let's keep going. Some more examples of expanding. Remember these steps here. Oops. It says to look for fractions, because when you look for fractions, you are then doing subtraction. So we are subtracting everything in this denominator. So please remember that. We are subtracting everything in the denominator. So subtraction of log 4x squared. The first part of this equation should be fairly simple to you because they're all positive. So you're breaking up now. We got rid of the fraction. Now we break up multiplication. Log 7 plus log y cubed. And then log 7, here's an exponent, becomes log y. So the first part should be set up fairly straightforward for you. The second part, though, you have to please remember that you are subtracting everything that's in there. So you're subtracting log 4 and subtracting log x squared. Everything in the denominator needs to be subtracted. So here's a an exponent again, so that becomes the new coefficient. And that's how you expand. We'll have another guided practice here in a minute, but right now let's do a quick condense. Looking for coefficients. Here is a coefficient, so make that an exponent. Look for addition and make it a product. Here we are adding some things, so it should be ln 3 times x squared. When you have subtraction, it means division. Basically, things being subtracted go in the denominator. And that is how we condense. All right, let's take a look at guided practice. This is 5 to 6. Okay, so number 5 says to expand log 3x to the 4th. All right, following the steps we just did here, there is no fraction, so we don't have to do the subtraction part. Let's do the product now. Product says that we break the multiplication up and add the two logarithms. The last step was to put the exponents in front. Log base 3 plus 4 log x. Number 6, condense ln 4 plus 3 ln 3 minus ln 12. Okay, you actually could, if you were asked to evaluate this, you could evaluate this by typing into your calculator. And before you did any work, you could do ln of 4, adding it to 3 ln 3, and then subtracting ln 12. And we should, at the end, get 2.197. But it's asking us to condense. So condensing, we put coefficients as exponents first. Rewrite it as ln 4 plus ln 3 cubed minus ln 12. All right, 3 cubed, you should be able to simplify. ln to the 27. Now, looking for addition stuff. Addition stuff goes in the numerator together. So it becomes ln 4 times 27 minus ln 12. 4 times 27, 108. And now we're looking at the subtraction. The subtraction means that we divide. The positive stuff goes in the numerator, the negative stuff goes in the denominator, and when you try and do 108 over 12, it simplifies to 9. So it's the ln of 9, which, when you type into the calculator, gives us 2.197. So that's condensing. Okay, so this should be easy since we've been talking about it for the past couple sections. We are looking at the change of base formula. We already should have been using it. Change of base formula says that you take log base C of A is equal to log base B of A log base B of C. And basically what you do is you take the numerator, let me see here. This right here becomes log of A divided by log of C. You could also use ln, the natural log, ln A, over ln c. Basically, you're using natural logs and common logs. Those are natural logs, this is a common log, to evaluate some of this stuff. So I shouldn't have to do too many of these. Right here, evaluate log base 6 of 11 using common logarithms. Well, common logarithms, you take the log of the big number and then you divide by the log of the little number, or the base. So in the calculator, you could just do log 11 over log 6, ln 6, which is approximately 1.3383. Or you could use ln, a big number, divided by ln of the base, or the little number, and you should also get 1.3383. Now in your calculator, this should be plenty for you to get the right answer. You may want to, at some point, put, depending what's the numerator, put extra parentheses there, but you do not have to. All right, change the base formula. Log of the big number divided by log of the base, or little number. So 26 goes up top, 16 goes down low, and you should end up with 1.1751. Over here, let's use natural log this time. Big number up top, little number down low, and you end up with 1.5937. All right, that is pretty much all there is for this. Guided practice. Let's go and look at some of the guided practice. I'm not going to do a whole lot. Let's look at 7. 7 says to take the log base 5 of 8. Use the change of base formula to do this. So big number goes up top, little number goes down low, and you get approximately 1.292. Number 9 says to do log base 9 of log, sorry, I got ahead of myself. Log base 26 of 9. So you do log, I say big number because 26 is written as a base. It's just physically smaller. Not numerically smaller, physically smaller. So log 9 over log 26 should give us approximately 0.674. Now I'm going to add a number here, add a page for number 11. Number 11 says, in example 5, suppose the artist turns up the volume so the sound intensity triples. How many decibels does the loudness increase? So in your textbook, it gives you a formula. It says that 10 log I over I sub 0. This is a formula that was given to you based on sound intensity. And it gives some information about it. It says, though, in example 5, suppose the artist turns up the volume so the sound intensity triples. So basically, we need to look back at example 5, pull out some information. Example 5 says, gives you some of the information. It says that I sub 0 is the intensity of a barely audible sound. It's about 10 to the negative 12 power. An artist is recording a studio, turns up the volume on a track so that the sound intensity doubles. All right. So basically what we're doing, if you follow that expression, that example, it says, first of all, that they want to know when the sound intensity doubles. So basically what we're doing, you're looking at the intensity that, in the example it said doubled, so it gave us L of 2I. Gave us this. You want to find the difference. So in this example it said that this is doubled of that. So now we're tripling it. And so now we use this formula, 10 log, well, I is now 2I, or I'm sorry, 3I over I sub 0. And you're subtracting 10 log I over I sub 0. And basically, we need to do some simplifying here. We need to try to condense some of this information. And there's a lot of ways you can go about this. You will probably recognize that there is a coefficient here, and that you could rewrite this as a power if you wanted to. What we're going to look at is we're going to keep that 10 though on the outside. Notice how it's a 10 here and a 10 there. We're going to undistribute. They're both divisible by 10. Take it out. Log 3I over I sub 0 minus log I over I sub 0. And we're going to look at some properties here. Check this out. This is multiplication. So you can make this log log 3 plus log I over I sub 0 minus log I over I sub 0. And the reason we wanted to follow this in these directions is that this part right here cancels out. So all that you have left is 10 log common log of 3, which when you type that into your calculator should give you 4.771 decibels. All right. So you should have a lot of information here. You should be able to get through quite a few of these homework problems. We will do some in class before you take your mastery. So good luck.